Hello and good afternoon, CSI257 Section 847 students for the first 8-week term of the spring 2015 semester for the Cisco Networking Academy Scaling Networks course, which is the Anne Arundel Community College Networking 3. And today's video tutorial is going to be a supplement to the lecture that we had on Saturday around EIGRP. And specifically what we're going to be taking a look at here is we're going to be taking a look at some debug messages. We're going to take a look at some query packets, and we're also going to take a deep dive into some of the key critical components that you need to understand with respect to EIGRP. Specifically, the successor, the feasible successor, the feasible distance, the reported distance, which is also commonly referred to as the advertised distance. And we're going to look at some of the EIGRP tables in depth. We're going to look at the EIGRP topology table, we're going to look at the neighbor table, and we're also going to take a look at the routing table. So if you take a look here on the left-hand side of my screen, this is going to be the reference architecture for our conversation. As you can see, we have 4 routers connected together. It's important to note that right here, that is a serial link, right? So the speed of this link is only 1.544 megabits per second, and this is just the representation that the FA01 interface here is connected to the FA01 interface on this side, and that is the subnet that those links are using. So we actually have kind of a elongated triangle here. So router 3 connects to 6 connects to 4, 4 connects to 5, 5 connects to 3. And this is going to allow us to take a look at what the feasible successor looks like, and not only that, but to get a chance to see what it takes to meet the feasibility condition. All right, so let's go ahead and we'll start off by first taking a look at the output from a show IP route. Also important to note, we've got some loopback interfaces here, and there's been a loopback interface configured on each of the routers, and these we're going to use to go ahead and compute the EIGRP composite metric. So let me go ahead and do a Control-C here. So this is router 3, right? So this is the router that you see on the far left-hand side of your screen. We're going to go from user exec into privilege exec, and I'm going to type show IP route. So as you can see, we've got a number of routes listed in the routing table here, and remember that EIGRP is going to display its routes with a D, and that D stands for dual, right? The diffusing update algorithm that is used by EIGRP to calculate its composite metric. So just taking a look at the routing table here, we are learning about this network, the 192.168.46.0. So this is between 4 and 6. So here's the network that we're looking at on the right-hand side in the show IP route output. We see the administrative distance is 90, right? And then what is this right next to the 90? Remember that that is going to be the feasible distance. In other words, this is the metric, and in OSPF terms, you could think of it as the cost, right? So this is my cost to go from router 3 to the 192.168.46.0 transit network here. My cost is $30,720. And then we have this via, right? Remember that what follows the via is my successor. And I apologize, it's not writing too well there. So that is, and in fact, let's go ahead and pull this off. So see if I can get a little better successor. So this is my successor. And the successor is the router to whom I'm going to send my traffic to get to this network segment. And so if we look at our diagram here, it makes sense that, and well, maybe it does, maybe it doesn't. We'll take a look here. It makes sense that we're going to take, in order for us to get to this network segment over here, we're going to go this way around the fast Ethernet connection, and then we arrive at the desired network, right? This is how long we've known about that network, so about 32 minutes. This is the interface out which I will go to get to that network. Okay, so again, we have the network that we're learning about. We're learning about it from EIGRP. We have the network and the subnet mask. We have our administrative distance for internal EIGRP, which is 90. Then it's followed by the cost, right, or as EIGRP refers to it, the feasible distance, the metric for me to get there, via this successor, right? This router here is going to be my next hop. We've known about it for 32 minutes, and it's going to be out interface fast Ethernet 00. So let's take a look at another entry. Let's take a look here at this 4.4.4.4, which is the loopback address on router 4. So we have the address that we're trying to get to. The administrative distance is 90 for internal EIGRP. And as you can see here, I've got a different metric, a different feasible distance, put FD in here, of 158,720 via this successor. And it turns out it's the same successor. So this may not be obvious at first glance, but it's easy. It's less of a cost for me to go from 3 over to 6 to 4 than it is to go from 3 to 5 across this serial link, right? Which is going to have a much higher cost. So again, this is telling me which way I'm going to go. And again, it's going to be out my fast Ethernet 0 interface. Now, if I was simply trying to go to my next door neighbor here, router 5, 5.5.5.5, you can see we've got the feasible distance here via, and this should be obvious, so we're directly connected to them. That's the route we're going to take, right? And it's going to be out the fast Ethernet 0 interface. So let's go ahead, let's clear our screen here. And on router 5, let's move over to router 5. Let's take a look at router 5 here. And let's do a show IP EIGRP topology on router 5. And we see some interesting things here. You'll notice that one of the things that we see in the topology table is that even though router 5 could go this way to get to 3.3.3.3, which is the address right here, the only entry we have for him to do that is to go this way to get there. Now, if you were just looking at this, again, at first blush, you're going to think, yeah, this is obvious, it's going to go this way. But again, he could go this way. However, in the topology table, we don't see that, right? We're not seeing that he could go that way. Now, remember, this is critical that if it's not a feasible successor, if it doesn't meet the feasibility condition, and what is the feasibility condition? If we look down here to the route to get to 6.6.6.6, we have one successor, and what that means is we have one route who was successful, or one router, I should say. I apologize, one route who was successful over all of the other routes. He had a lower cost than all of the other routes. He has been chosen as the single successor. His feasible distance is 158,720. And we see that right here, right? That is the feasible distance for the route to get to that route via this successor. And so this is the route out fast Ethernet 00 that shows up in the routing table. So if I were to say show, oops, let me click in here. If I were to say show IP route and hit enter, when we see 6.6.6.6, you'll notice there's only a single entry here. And it's the entry that we see right here via 192.168.35.5 out fast Ethernet 0. However, the topology table is showing us an alternate path to get there. So from router 5's perspective, and here we are in router 5 says to get to 6.6.6.6, I'm going to go this way. I'm going to go to 3 and then over to 6 to get there. However, he also has a feasible successor. And that's why this route is displayed here. If they had the same cost, you would have multiple successors. So instead of saying one successor, it would say 2. Or if we had 3 paths to get there, it would say 3. So what is the feasibility condition? What condition has to be met so that this route right here, the second route that we see, gets installed in the topology table? So basically, this is a backup route that EIGRP is saying, we're putting this in the topology table. I've already done the calculations, as you can see, right? I've already done my calculations, and so I've got this guy on hot standby, ready to go in case fast Ethernet 00 goes down. And so what is the feasibility condition, right? So the feasibility condition is that if my reported distance, right, the RD for this router, which is router 4, if router 4's reported distance, and let me put a little thing over here, this is his reported distance to get to 6.6.6.6, if the reported distance is less than the feasible distance of the successor, right, then this meets the feasibility condition that we're talking about. So that's all you've got to check, is you got to check to see, is the reported distance less than the feasible distance of the successor? So if this is true, then the route gets installed into the topology table. Because what EIGRP is saying is that I can guarantee that because this reported distance is less than the current feasible distance, it's impossible that he's going through the successor to come up with that number. Does that make sense? So hopefully that makes sense. So again, we'll take one more pass at this here. So our reported distance is 156.160, and that is less than the current feasible distance of the successor. And the successor is this one here listed first, router 3. Because the feasible distance of the successor is 158.720. So this is true, and if this is true, then EIGRP says I can guarantee that because the reported distance is less than the feasible distance of the current successor, it's impossible for the feasible successor to be coming through the current successor. And that is how EIGRP guarantees a loop-free topology and how it takes advantage of additional paths that it has. As long as they meet the feasibility condition, those routes get added into the topology table. And here's the benefit of that. If Fast Ethernet 00 were to go down, Dual would not have to do a complete calculation to figure out what is my next best route. And the reason for this, and let me clear the screen here, the reason for this is that Dual already did that. So Dual already knows that if this link goes down, Fast Ethernet 00, this will simply be moved from the topology table directly into the routing table. And again, remember, at present, we don't see this route in the routing table because he is a feasible successor. Okay? He's a feasible successor. And so then what's this first number here? So the reported distance is the second number. And this is one of the challenges for new learners with EIGRP is there are a lot of numbers. They are not small and they're all over the place. And so when we look at this, right, this is the this is the reported distance for this feasible successor here, right? This would be the feasible distance if this route, so the first value here, that would be the feasible distance when it goes into the routing table. And that is the current reported distance. Okay? And so again, this is the reported distance up here, and this is the feasible distance. And so the feasibility condition, I apologize, let me clear the screen one more time, just to be clear. So the feasibility condition says, if the reported distance of the non-successor is less than the feasible distance of the current successor, this guy meets the feasibility condition and will be installed into the topology table as a backup route who's literally on hot standby waiting for Fast Ethernet 00 to go down. And so when Fast Ethernet 00 goes down, when we do a show IP route, we're going to see this route, and it's going to show us that this is the feasible distance for the route. So let's go ahead. Let's knock that out right now. And I am going to go on to, I'm on router 5, and we're going to go into interface Fast Ethernet 00, and I'm just going to say shut. Right? Now you can see that the adjacency goes down. And if I were to now say do show IP route, what are we going to see for our route now to get to 3.3.3.3? And so here's what we see, 230.2976. Let's scroll back up and let's see what our topology table showed us. 230, where are we at here? 230.296. So we've got 155 or 192, 168, 54.4. And let me make sure I'm looking at the right thing. So that would have been the feasible distance if the feasible successor was going through router 4 to get to 3. And so now we're showing that. Let me run the, let's do the do show IP EIGRP topology. Let's make sure we've got the right thing in here. So here it is right here. So we have a single successor now. And it looked like that value changed on us. I believe the value changed 54.4. Oh, I'm sorry. It did not. So 2300416, 2300416. I apologize. I was looking back up here. So we were looking at 6.6.6. I apologize. I got caught here on 3.3.3 thinking that that was our feasible distance number that we were trying to double check. It is not. That's what we're trying to double check. And so you can see that the feasible distance is now 230.0416, and that was the exact same number that the topology table already had queued up, ready to go, excuse me, because this feasible successor met the feasibility condition and therefore was installed into the EIGRP topology table, meaning that EIGRP doesn't have to do a dual recalculation. It simply moves that route from the topology table into the routing table, giving us sub-second failover. And so let's do this. I'm going to say no shut. Excuse me. We're going to bring that interface back up. And as you can see here, the neighbor adjacency comes back up. If I do a do show IP route, what we would expect to see for 6.6.6 is, once again, you can see how quickly that happened. The traffic is now flowing back through router 3, going this way to the left, and then down to 6 to get to 6666. So here's what we're going to do on router 4, right? So because router 4, let's see what router 4 thinks about that 6.6.6.6 network. We'll go from user exec to privilege exec, and then into global config, and or actually we can just stay in privilege exec. And so what we're going to say here is I'm going to say trace 6.6.6.6, and let's see which way. And from looking at the diagram above, it should be pretty obvious which way it's going to go. And it looks like it's going to go directly over that 192.168.46 transit network to get to router 6. And it does. And that's it. So let's see if I do a show IP EIGRP topology on router 4, does he have the same thing that router 5 has? Does he have a feasible successor to get to 6666? He does not. He has a single successor. Here is the feasible distance. This is his reported distance. And he's going to take the link via the successor, router 6. So there is no feasible successor here. So what does that mean? Remember, router 5, he says, you know what, if this link goes away, I have a feasible successor, and it's going to be router 4. And then I'm going to jump over here to get to router 6 to get to where I'm trying to go. However, router 4 says, if this link goes away, I don't have a feasible successor. He does have a backup path, but it's not a feasible successor because it doesn't meet the feasibility condition. And the reason that it wouldn't meet the feasibility condition, if you think about it, we're looking at it right here, is what we're saying is that router 5's reported distance to get here is going to be greater than the feasible distance of the current successor. So whatever that number is, it's got to be greater than 156.160. So the question is, how do I see that, right? What's the easy way to see that? Because if there's not a command to type to see that information, you would literally have to calculate it by hand, and that's not going to be fun. So here's what we're going to do. And this is a command from chapter 7. It's show IP EIGRP topology. If we do the question mark, you can see we want to see all links, right? So what all links is going to do is it's going to show us the topology table, but it's going to show us the topology table in a form, or in the format where we have every possible route, whether it's a feasible successor or not. And so here is 6.6.6.6. So here is my successor through router 6. And that's what we're seeing in the routing table. That's also what we saw above in the topology table. But now let's take a look. Remember, router 5, what is his reported distance? Router 5's reported distance is 1 put it out here, 158,720. Well, 158,720 is greater than the feasible distance of the current successor, which is 156,160. And since the reported distance of a possible successor is greater than, this is again reported distance, is greater than the feasible distance of the current successor, it does not meet the feasibility condition. And therefore, this second route here, which is a legitimate, valid route to get to 6666, if that link went down, this route is not going to be put in the topology table, because EIGRP cannot guarantee that this second route right here that you're looking at via the 192.168.54.5, that's via router 5, from router 4's perspective going to the left to router 5, EIGRP can't say that that route does not come back through me, because the feasible distance of that route is greater than, the reported distance of that route is greater than the feasible distance of the current successor. So mathematically, it could be possible that this second route here would come through router 4 going to the right of the diagram, going this way, because it could add that number in and give you the number that's greater than the feasible distance. And so again, that's why the reported distance has to be less than the feasible distance, because that and only that will guarantee that it's impossible for the route with the reported distance being less than the feasible distance. That means that that route could not and will not and cannot be going through and using that router or that route as its transit point, how it's getting to the 6.6.6.6. And hopefully that makes sense. And so that's why the all links command is important, because then I can come in here and take a look and say, okay, well, I can clearly see the reported distance of router 5's route to get to 6666 is greater than the feasible distance of the current successor. Therefore, feasibility condition not met. So we will not see this route in the topology table sitting there ready to go as sort of a hot standby to take over should this link go down, right? Okay, let me clear the screen here and we'll scoot back. So that's, hopefully that makes sense, the feasibility condition and what is required for the feasibility condition to be met. So here's what we're going to do. So that's a backup route, right? Actually, let me go ahead and make sure I'm clear on this. So router 4 going through router 5, that is a legitimate route. You can see that EIGRP has calculated things here. It's just that it doesn't meet the feasibility condition. So I'm going to do an extended ping here. Let's ping 6.6.6.6. And as you can see, we've got connectivity. It works great. So now I'm going to do an extended ping, and we'll throw a really big number out there. So I'm going to hit enter, right? And as you can see, the traffic is flowing perfectly from 4 over to 6. But now let's go over to router 6, and we're going to see how many pings we miss when I go into global config and then interface fast Ethernet 00. I'm going to shut that interface down. Now dual and EIGRP are going to have to recalculate the backup path. They're going to have to do a full recalculation to figure out which way do we go now. Now again, the feasible successor for this route, or to 6666, is not in the topology table. So if I were to say shut and then step over here to router 4 as quick as I can, let's see how many pings we miss. 1, 2, right? So we missed 3. So we missed 3 pings, and hopefully you're able to see that. We missed 3 pings there. So it basically took 3 pings for EIGRP and dual to do the recalculation and get that backup route, it wasn't a feasible successor, right? But to get that secondary route recalculated and then inserted into the routing table, and then traffic is automatically flowing again. So I'm going to do a Control-Shift-6, and we're going to quit out here. I'll bring that interface back up. So we missed out on 3 pings, right? So let's go ahead and say no shut. We're going to bring the interface back up. And let me come over here to router 3, and then we'll make sure that we're still on router 5 here. So when I did the do show IP EIGRP topology on router 5, this is going to make for a good use case here to see, is it any faster when we already have a feasible successor in the topology table, right? The only thing that has to happen here is that route is going to be moved immediately, instantaneously, into the routing table. But let's see how this is going to work. So what I'm going to do, and we're going to go to 6.6.6.6, is right now, router 5's preferred path is through router 3. Okay? So if I were to say do trace over to the 6.6.6.6, we should jump over to the 192.168.35.3. Then it should jump to the 192.168.36.6. And then we should arrive at our destination. Because remember, we're going from right to left right now in terms of the preferred flow of traffic. It's going this way to get to router 6. And we know it's doing that because we've got this really slow serial link in the middle here, right? So there you go. It went to 3, and then it went over to router 6, and then it made it to where it was going. So here's how we're going to tee this up. So on router 5, whoops, sorry about that, and I do not need to see that. Let's get this out of here. Sorry about that. So on router 5, I'm going to go ahead and do an extended ping here. We're going to say do ping 6.6.6.6, and I'm going to say repeat, and we'll put a big number in here. So now this is going to go ahead and ping away. But now we're going to step over to router 3, and I'm going to take down the FA00 interface. I'm going to take away router 5's ability to go this way with traffic, to go to 3 and then to 6. So I'm going to say, we'll go to global config mode, interface FA00, and then what are we going to say? We're simply going to say shut. And let me move myself up here, make sure that I'm really close. Let's see, 3 pings on the first one, right? As soon as I hit shut here, that interface is going to go down. Let's see how many pings we miss when we have a feasible successor in the topology table ready to be inserted into the routing table. I hit enter, I click over, let's see. 1. So we only missed 2, right? So we ended up missing 2 pings instead of 3 pings. So it is, I don't want to say much quicker and not twice as fast, but it could be pretty close, right? So again, you can see that it was a little quicker when the route is already a feasible successor sitting in the EIGRP topology table, okay? And again, right, it's not that the network is not going to work when the link goes down if it's not a feasible successor. It's just that it's a little quicker. And so this is how EIGRP has a minor advantage. And again, there are other things, there are other settings called LFA, loop-free alternate, that both OSPF and EIGRP use today, that sort of mitigate the differences in the convergence time. But when we're just looking at it like this used to be one of the major arguments, was that EIGRP could converge quicker because it had that sort of hot backup route already calculated, already sitting in the topology table, just waiting for that failure, and then boom, he would immediately get inserted into the routing table, and then traffic would continue on, as you see here. So let's say Control-Shift-6. You probably don't want to watch that too much longer. All right, so that's our conversation about the successor, the feasible successor. The final thing I want to do is let's take another look at the metrics, right, about the EIGRP. I'm going to clear some space up here. So if I type in show IP route, right, and if we wanted to figure out from router 3's perspective, how would I get to 4.4.4.4, we would come here and we'd see we're learning that, and then here is the feasible distance for that route. It's 158,720, and we're going via, right, who's our successor? The successor is router 6. We've known about it for it's been in the routing table for 4 minutes and 49 seconds, and the outgoing interface that I'm going to send my traffic to get there is fast Ethernet 0.1. So the question now becomes, how is this value calculated, right? So in looking at this from router 3's perspective, 3 is going to go to 6, and then he's going to come over to 4, and that's how he reaches this loopback address. Now, the key thing to remember is the loopback address will have a cost, right? There will be a delay and a bandwidth setting on that interface. So let's go ahead and let's do this calculation right now. So again, remember that the composite metric for EIGRP by default is calculated using the K1 and the K3 values. And those values are respectively the bandwidth and specifically the slowest link along the path and the delay. And with the delay being the K3 metric, it is specifically the cumulative delay that we are going to be interested in. So let's go ahead and we can actually see here, we have fast Ethernet interfaces the whole way. But I need to see on router 3, show interface fast Ethernet 0.1, the outgoing interface, right? What is my bandwidth is 100,000 in kilobits per second because it's a 100 meg interface, and my delay is 100. So I'm going to go ahead and add the delay up over here. So we're going to say 100 plus. So we know we've got 100 on the first outgoing interface. The next outgoing interface is FA00 on router 6. And so as we would expect, if I said do show interface FA00, we're going to see the same thing that we just saw, because again, it's a fast Ethernet interface. The bandwidth is still 100,000 in kilobits per second, and the delay is 100 microseconds. So we're going to say plus 100 plus the outgoing interface, because remember, when the traffic comes in here, this is the loopback address is the outgoing interface. So on router 4, where we were just going doing a lot of pings there, we're going to go ahead and say show interface loopback 0. Now, the loopback interface is far greater than 2.3. It's 8 million, right? 8 million kilobits per second, which is greater than the 100,000 that we saw for the fast Ethernet interfaces. So we know that this value is not what we're going to use. We're going to use 100,000. And we're going to come right back to that. But right now we're interested in the delay. As you can see, the delay here, it's 5,000. So let's add 5,000 in here. 5000 equals 5,200. So I'm going to come back over and I'm going to free some space up here so that we can get the calculation done. So again, the EIGRP composite metric, and I'll just put down here the EIGRP metric. This is how it's calculated. You basically take 10 to the 7 divided by, and I'm going to put down the slowest bandwidth along the link, plus the cumulative delay times 256. And so what does that give us? That gives us, so we'll do 1, 2, 3, 4, 5, 6, 7. So 1, 2, 3, 1, 2, 3. So 10 million divided by, what was our slowest bandwidth? Well, it was 100,000. And we're going to add that to our cumulative delay, which we added up is 5,200. And I apologize, it's 5,200 divided by 10. And we're going to divide that guy by 10. And then we're going to multiply this whole thing by 256. So let's go ahead and see. We'll deal with the left-hand side of the equation first. So right here, pretty easy, right? We just drop the zeros out, so we end up with 520. So our delay K3 value is going to be 520. What about our K1 bandwidth value? Well, we've got 1, 2, 3, 4, 5. So let's drop 1, 2, 3, 4, 5 zeros. Leaves us with 100. So the left-hand side of the equation is basically 100 plus 520. So we've got 620 times 256. And that is something I cannot work out in my head. So we're going to come down here and I'm going to say 620 times 5. Oh, I'm sorry. Clear that out. 620 times 256. And we end up with a number that should look pretty familiar to you. And that number is 158,720. So, from R3's perspective, his feasible distance to get to, and we said we're going, I believe we said we're going to 4.4.4.4, we should see 158,720. And even with that big mess on the screen, let's go ahead and say show IP route. And what do we have? We have, where's 6.6.6.6? Or I'm sorry, 4.4.4.4. I apologize. Here we go. Right there, 158,720. So let me clear this actually. So we said 158,720 to get to the 4.4.4.4, and sure enough, that is how that number is calculated. Again, it's actually not as complicated as they make it look, especially when you're only using the bandwidth and the delay. The key to remember is it's the slowest bandwidth and it's the cumulative delay. And then the final question, or I mean the final piece of the puzzle, is why 256? Why are we multiplying it by 256? And the reason goes back to what the chapter initially started with when it talked about the Interior Gateway Routing Protocol, IGRP, which was classful, but the key is that it was also only 24 bits, right? So we multiply the values by 256 to make everything 32, to make sure that the values would end up at 32 bits, right? So that's why it gets multiplied by 256, because this is one of the things that was taken from IGRP when EIGRP was created. And so that's why that is why you will often see in that big equation things are being multiplied by 256, because initially IGRP was only 24 bits. So by multiplying by 256, it makes it 32 bits. Makes the values 32 bits. So that's why you see this times 256. And so again, that is how you calculate the feasible distance, right, for a route. And again, key to remember, cumulative delay, slowest interface. And that's the key, cumulative delay, slowest interface. All right, so while we're here, let's go ahead and we might as well take a look at EIGRP IPv6 or EIGRP for IPv6. And let's go ahead, and we're actually we'll do each of the little configuration pieces. And so we'll go to global config, we'll do interface fast Ethernet 00 first, where I'm going to say, and actually before I do that, I'm going to probably have to say IPv6 what? Unicast routing, right? We want to enable IPv6 routing. And so here's where I'm going to go into the interfaces, and we're just simply going to assign some link locals, and we're going to say IPv6 address FE80::3, because we're on router 3, link local. And then we're going to go into FA01, and we're going to do the same thing. We're going to say IPv6 address FE80::3 for the link local. And I might as well, we'll go ahead and let me put some full-blown IPv6 addresses on here. And so I'll say IPv6 address 2001:DB8:ACAD:, and this is going to be, we'll say 36::3 with a prefix length of /64, and then I got to get back into FA00 to do the same thing. And we'll roll back over this, and this is going to be 35::3/64. All right, then let's go on to router 5. And the first thing we need to do is to go into global config and type in the IPv6 unicast routing command to enable IPv6. And then we can jump into our interfaces. So we'll start with FA00, and I'm going to say IPv6 address is FE80::5 link local. And then we'll say IPv6 address, and we'll use 2001:DB8:ACAD:35::5 with a prefix length of /64. And let's go into serial 010, and let's say IPv6 address FE80::5 link local. IPv6 address 2001:DB8:ACAD:, and this is going to be 54::5 with a prefix length of /64. And now let's move on over to router 4 here, and we're going to do the configuration for router 4. We're going to first enable IPv6 unicast routing, and let's go ahead and say interface serial 010. IPv6 address is going to be FE80::4 link local. Whoops, typo there. And then IPv6 address is going to be 2001:DB8:ACAD:, and this is 54::4/64. And then let's go into FA00. Let's give ourselves a link local address, IPv6. Whoops, not Lisp. IPv6 address FE80::4 link local, and IPv6 address 2001:DB8:ACAD:, and 46 is our segment there, and :4/64. All right, so that takes care of router 4, and then last but not least, let's get router 6 IPv6'd up here. And we've got, we'll go to global config, IPv6 unicast routing, and let's go into FA00, and we're going to say IPv6 address FE80::6 link local, and then IPv6 address 2001:DB8:ACAD:, 46::6/64. And then last but not least, FA01, IPv6 address FE80::6 link local, and IPv6 address 2001:DB8:ACAD:, and we're looking at 36 there. 36, is that right? 36. I'm sorry. :36::6/64. All right. So, quick topic, right? So EIGRP for IPv6 has the same tables that the EIGRP for IPv4 has. You're going to have a neighbor table, you're going to have the topology table, and you're going to have the routing table. The only difference is you're going to have to use the IPv6 command to see that information. So instead of show IP EIGRP topology to see the topology table, we would say show IPv6 EIGRP topology. And just like OSPF, right, whether it's OSPF v2 or v3, EIGRP follows the same convention when we're talking about the router ID. Even with EIGRP for IPv6, the router ID remains a 32-bit value that is represented in IPv4 address format. And it's the same with OSPF v3, which is OSPF with IPv6. All right, so we have the link local addresses configured, right? And it's exactly those same IPv6 link local addresses that allow the devices to communicate with other devices that are running IPv6. And so when we talk about EIGRP for IPv6, make sure that you note that the source address for the packets is going to be the link local. This is for the EIGRP messages that are being sent. The source address is the IPv6 link local address on the exit interface, right? Not the global address that we've configured starting with 2001. It's going to be the link local address. All right, so we've got the addresses configured. Let's now go ahead and jump in and let's set up EIGRP for IPv6. And the command syntax is a little different. I'm going to start here. We'll go from left to right. So let's start ourselves out here on router 3. And didn't want to jump all the way out there. I want to stay in global config. So before, where we would type in router router EIGRP and then the autonomous system number, IPv6 is a little different. So I'm going to say IPv6 router, and if I do the question mark, you can see I get a choice here. And I'm going to say EIGRP, and then what would follow? Exactly, the autonomous system number. So we're going to keep it as 1 because that's what it currently is. So if I do the question mark, you can see that we've got some different options, very similar to EIGRP for IPv4. Let's set the router ID. So EIGRP router ID for router 3 is still going to be 3.3.3.3. Now, if I do a do show run section EIGRP, we see something very interesting here, right? Now remember, this router that I'm on, do show version, this is running 12.4 24T2 code. And what do you see here that should alarm you immediately? If you're looking at where it says shutdown, you've got it, right? So by default, with the 12.4, at least this branch of the 12.4 code that I'm running, your EIGRP process is going to show itself as it's going to be shut down right now. And so that is a major concern. So obviously we're right here in the EIGRP configuration, so we're going to say no shutdown, right? So now if I ran that command again, do show run section EIGRP, you can now see that it's not shut down. Okay, and remember, I've got the information here for these Cisco 1841 routers, right? These two guys on the left, 3 and 5, are running 12.4. Let's see what the behavior is over here with the 15.3 code. So we just went ahead and shut the process down. Now you'll notice when I do the question mark, something interesting here. Where is the network command? We don't see the network command here. And that's because EIGRP for IPv6 does not have the network command. So what we have to do is we're going to actually have to go under the interfaces, the actual interfaces, to do that configuration. And it's actually very straightforward. It's not too complicated. So I'm going to say interface FA00, and it's literally IPv6 EIGRP, and then what's my autonomous system number? So this interface, FA00, is going to be running EIGRP for IPv6 and autonomous system number 1. And that's it. It's very similar to the network command because it's going to start the EIGRP for IPv6 process on that interface. However, we don't use the network command. So let's wrap this up. Let's go to, at least on router 3, to FA01, and let's say IPv6 EIGRP 1. So now both of those interfaces, if I do a do show IPv6 topology and, oh, sorry, IPv6 EIGRP topology, and let's take a look. So what do we have so far, right? So we see that we've got the 36 network set up, or our link to the 36 network, and I may have configured IPv6 on router 6 earlier, or at least thrown a link local address on there. So we see the entry here, right? What about a do show IPv6 route? Okay, so you can see we've got our directly connected route, right? For the 36 network, we've got our local entry for the 36 network, and we also have our link, our local entry to null 0. So let me now go ahead, step over to router 5. We'll continue going left to right here. So we've got our addresses in here, and we did that. So we're good to go here. Let's say, whoops, IPv6 router, and then what are we going to do? EIGRP, autonomous system number, we'll keep it with 1. So I'm going to set my router ID, EIGRP router ID for router 5 is simply 5555. And that, I believe, yes, so do show run section EIGRP. Let's see if this is shut down as well, and it is. So we're going to say no shutdown. We're going to bring them up, right? Let's hit our interfaces now. So interface FA00, and I'm going to say IPv6, EIGRP, and our autonomous system number. And now that was FA00, who should be adjacent with router 3, and let's see if we get an adjacency to establish here or not. Let me go into interface while that's doing that. Serial 010, IPv6, EIGRP, autonomous system number 1 on the serial link there. So what if I do a do show IPv6, EIGRP neighbors? As you can see, we have no neighbors right now. So the adjacency didn't establish with router 3. Let me double check, because did I not IPv6 EIGRP 1? : did I not set that up on do show run interface FA00? Okay, ACAD35::3 DB8. The link local is there. Interesting. The interface. Oh, maybe from a previous. Oops, sorry. No shut. Yeah, for whatever reason that interface was shut down. So there we go. And as you can see, we've got an adjacencies coming up. We have our IPv6 adjacency now, which is what I was desperately hoping for over here when I was on 5, not realizing that the interface, I had shut that down at some point, I guess. Okay, so now let's do the do show IPv6 EIGRP. Let's take a look at the topology table. And so it very similar, right? Sure, we've got these IPv6 addresses in here, a little bigger, a little more to look at and digest, but look at the format. It's identical. We've got one successor, right, via connected fast Ethernet. And we see we've got the same values here, right? We have our feasible distance, we have our reported distances, and it tells you right here the feasible distance. So this number here, feasible distance 28,160, when you see it here, it's going to match, right? And we're going to get, we'll add some additional info. You'll see some additional information as we configure on, we move on with the config. So let me do a do show run, and I think we did interface serial 010. I want to check before we move on here. 010, and he's good to go. So let's now step over to router 4 for some IPv6 work. So we're going to go from user exec to privilege exec into global config. And on router 4, let's go ahead and say IPv6, unicast routing. And now remember, do show version. If you take a look here at router, we're on 4. Router 4 is running 15.3 code. So let's see how router 4 behaves when we get into the IPv6 configuration. So the first thing that I'm going to do is I'm going to say IPv6 router EIGRP and then our autonomous system number 1. Let's get our router ID set, and EIGRP router ID is going to be 4.4.4.4, and then that's pretty much it. But let's see, do show run section EIGRP. Is my process shut down? It is not. So that is a significant difference that you definitely want to keep in your back pocket, is realizing that with the 15 branch of code, and again, I'm running 15.3, you should see in the 15.x branch, and I obviously haven't tested every release in 15, but generally in 15 code, the EIGRP for IPv6 process should not be in a shutdown state when you do your configuration under the IPv6 router EIGRP global config area, right, or global config section, like we just did right here. But with the 12.4 code, be wary or be aware that chances are your config for IPv6 router EIGRP is going to be shut down automatically, right? So we don't have to worry about that here. Let's jump into our interfaces. So serial 010 to start. So we're going to say IPv6 EIGRP autonomous system 1. We should see an adjacency here. And there we go. Fantastic. With router 5. And let's go into fast Ethernet 00. And I'm going to say IPv6 EIGRP 1 for autonomous system 1. No adjacency here yet because we've got our last router to configure, which is going to be router 6. So we go from user exec to privilege exec into global config, and one of the first things we want to say is IPv6 unicast routing. And then we're going to say IPv6 router EIGRP 1. And I'm going to say router, leftover from the OSPF days where you simply type router ID. So EIGRP router ID is simply 6.6.6.6, and now that's it. So what version of code is this guy running? He is also running the 15.3 branch of code. So just like router 4, when I do a do show run section EIGRP, what are we going to see? We're going to see that it's not shut down by default like it was with the 12.4 code routers, router 3 and router 5. So with that being the case, let's jump into the interfaces. We're going to go into interface FA00, and I'm going to say IPv6 EIGRP1. We should have an adjacency pop up here, and there it is. And last but not least, we're going to say interface FA01, IPv6 EIGRP1, and that's it. And then we've got our adjacency pop up here. So now from router 6's perspective, let's take a look and let's run a few of the commands that you're going to see in your text in chapter 7. So we've got show IPv6 protocols, right? So here's our information about IPv6 protocols. We can see that these are the protocols for autonomous system 1. Here are my metric weights, right? K1, K2, K3, K4, and K5. Keeping in mind that only K1 bandwidth and K3 delay are accounted for. We see the distances, right? Internal administrative distance is 90, external 170. Maximum number of paths is 16. My max hop count, again, is 100. And here are the two interfaces on which IPv6, EIGRP for IPv6 are running. All right, so that's the show IPv6 protocols. Now let's take a look at the neighbor table, see what we've got going on there. So let's say show IPv6 EIGRP neighbors. Okay, and again, it should look very similar, right? I mean, this is pretty much the same as it was with IPv4. So we have our H column, right? And if you remember, the H column is simply lists the neighbors in the order that they were learned, right? So remember, from the most recent, so we did the connection on 3 second. So let me reset here. So make sure we're clear on this. So the H column, right? So it starts at 0. So this is the first one that we learned. However, that also makes it older than this entry. And so the H column will list the entries and give you the number so that you know in what order they were learned, with 0 being first and 1 being second. However, when we display them with the show IPv6 EIGRP neighbors command, it puts the most recently learned entry on top of the older entry, right? So hopefully that's clear. Hopefully I was able to articulate that. So then again, remember, we're going to be looking at our link local addresses. Those are the addresses IPv6 is interested in with the adjacency. And then here's the interface on which those are the local interfaces, right? So on router 6, these are router 6 interfaces on which he's receiving EIGRP for IPv6 hello packets. Okay? You've got the hold time, and that's the number of seconds that are remaining until the adjacency goes down. So just like the dead timer with EIGRP, and let's see if we can catch it. It's tough to catch it. I don't think you can ever get it at 15. And it goes down every 5 seconds. We should get a packet. And you can see it's pretty tough. I can't even get it at 10. Oh, yeah, there we go. So we got them both at 10 right there. And can't get it at 15. I don't think I've ever captured it like at 15. So, but again, it goes to 10. We get a new hello packet, and then boom, goes right back up. Then we have our uptime. That's the amount of time since this neighbor was added to the neighbor table, right? So for the most recent route, 3 minutes and 29 seconds. And again, this is also a good way to see that this is newer than this, which is why this first entry here, even though it's got the number 1, which is greater than 0, that's why he's listed above 0. Because this output will be ordered chronologically based on when the routes were learned. All right, so then you've got your smooth round trip timer. And the smooth round trip timer and the RTO, these are used by the Reliable Transport Protocol, RTP, to manage reliable EIGRP packet delivery. So it gives us the sort of the average of what it's taking those, or how long it's taking those packets to move around, go from point to point. And then you've got the RTO, right, which goes with the smooth round trip timer. Most importantly is the queue count. The queue count should always be 0. If you see your queue count starting to increment, that means you have a problem in your network. Sequence number simply tracks the updates, the queries, the reply packets, and that's about it for the output here. So let's go ahead now and let's take a look. Let's take one more look at the routing table now. So if I said show IPv6 route EIGRP, this is going to show us the routes that router 6 is learning via EIGRP. Now I'm not redistributing. I don't have any IPv6 loopback addresses. So all I'm going to see are the transit, or not so much the transit links, but this is from router 6's perspective. I'm seeing 54, yeah, the transit network between 5 and 4, and the transit network between 3 and 5. And again, I've got my administrative distance here, as well as the feasible distance, or my cost to get there. And here's the successor. And again, instead of an IPv4 address, it's just an IPv6 address. So my successor, which is the router I'm going to with any traffic destined to this segment here, is going to be router 4, out fast Ethernet 0, 0, right? Okay, so we've covered a lot of ground here, right? We were able to talk about some supplemental things with IPv4, specifically the successor, the feasible successor, the feasibility condition. We took an in-depth look at the topology table, the neighbor table, the routing table. We even configured or calculated the feasible distance metric, trying to break it down into a digestible format instead of this esoteric equation that they give you if you were using all 5 values. However, by default, how many are we using? We're using 2. And keep in mind, and it's a key point, it's bandwidth and delay. It's the lowest outgoing interface bandwidth along the path, followed by the cumulative delay of all of the outgoing interfaces along the path. And if you're going to a loopback address, that is an interface, and you do need to take that interface into account, or else your calculation is going to come up a little skewed. We also then took a look at EIGRP for IPv6. We threw some IPv6 link local addresses, some global unicast addresses on the interfaces. We then went ahead and configured the global EIGRP for IPv6 section. One of the most important things that we saw was the behavior between 12.4 code and 15.3 code, which is on 12.4 code. What ended up happening to us? Every time we did our IPv6 router EIGRP1, it was in a shutdown state, right? Which means we had to say no shutdown to bring it up. With 15.3 code, no worries there. We configured router or IPv6 router EIGRP1, and it wasn't shut down. So it was automatically enabled. And on 15 code, that's the way it should be, but it doesn't hurt to check, right? Configure it, do a quick show run, pipe it, and so show run, and pipe it to section EIGRP and take a quick look. And you'll know if you're expecting an adjacency to form and establish, and it doesn't, this is the first thing I would check. The second thing I would check is the autonomous system number to make sure that those match. Because just like IPv4, with EIGRP for IPv6, the autonomous system numbers must match, or you are not going to see your adjacency established. All right, well, that wraps up this supplemental tutorial on EIGRP. I will see you guys all on Saturday, and hopefully this has cleared up any confusion that you might have had from the chapter. All right, enjoy the rest of your weekend.